All right, hello. So today we're going to be looking at antiderivatives for no apparent reason. I'm going to start antifreeze. And this damn pen is going to erase because, of course, antiderivatives. And they are the opposite of doing a derivative, obviously. So on some things, for instance, we learned about the power rule. So you have x to the n. The derivative of x to the n, of course, is n times x to the n minus 1. Well, if we're doing antiderivatives, we're going to actually write it like this for no apparent reason. If we take the antiderivative, you will get x to the n plus 1, because you add 1 to the exponent, and you divide by n plus 1. This is the power rule for antiderivatives. In essence, instead of minusing 1 off of that and then timesing out front, we're just going to add 1 up here, and then we're going to divide by on the bottom. Okay? So for nice easy ones like this, hey, find the antiderivative of 2x cubed minus 6x squared minus whatever. Hot diggity. So this becomes x to the 4 divided by 4 minus 6x cubed over 3 plus 5x squared over 2 minus x. Okay, now here's a kicker. I forgot on the previous one. You must always put a plus c, right? And what does that mean exactly? Plus c. And what that means is this, is whenever you take the derivative of a constant like 2 or 5 or 7, what happens to it? Well, it goes away. So you do the antiderivative, there's always going to be some constant there. Could the constant be 5? Yes. 0? Sure. Do we know what it is? No. So we put plus c. That's a big deal. Obviously, this should be reduced. This one doesn't reduce. Yay, and the crowd goes wild. Okay. Now we get to we're blue in the face. There's some other ones that you will see that you're like, oh, I know that guy. Sure, of course you do. This is the ln of. Now here's where it's a little fancier though. It's the ln of x with absolute values. And why is that? Because ln of x, when we do it originally, we say let's take the derivative of the natural log. The natural log, by definition, is only over here. And so we say it's 1 over x. But it's implied that this is only when x is bigger than 0, yes? This guy here only has x not equal 0. Therefore, we need the antiderivative to work on both cases. So we do this, and what we end up with is this guy. Okay? What does the derivative of him look like? On this side, it's down here, negative slopes, right? And up here, it's positive slopes. Yay, which is just 1 over x. Okay, it's just, I'm sorry, back here, sorry. This guy is all reals except 0. This guy is all reals except 0. What about sine, Groom? What about sine? Who is sine the derivative of? Well, it's the derivative of negative cosine. How do I know that? Well, what's the derivative of negative cosine? The derivative of negative cosine is positive sine. Okay? What's the integral of cosine? The integral of cosine is sine of x. Because the derivative of sine is just cosine. Yeah? Now, there's going to be some that you'll come across, you're like, oh, I know that one. Of course you do, like this one here, for instance. 1 over x squared plus 1, which we'll do some more of later on. Like, I know this one, Groom. This one's easy. It's arctangent. I know. We'll get to there later on. No, you want to memorize every single one of these, but a lot of these you will commit to memory. But mostly just because you do them often enough. Okay? So, plus c, of course. Plus, because there could have been a plus 5 on the end of that. It wouldn't make any difference. The derivative is still 1 over x squared plus 1. Okay? I know what you're thinking. What about the integral of e to the x? Or what's the antiderivative of e to the x? It's e to the x. Yay! Plus c, of course. But Groom, what if there was what if it was e to the 2x? Well, it turns out that it's e to the 2x times a half plus c. Is there a good way to remember how to do that? Yeah, there's actually a theorem for that. This is a function in a function. And instead of doing the chain rule, we're going to do a different situation, but it's basically doing the chain rule backwards. Okay, which shouldn't shock you at all. We start doing these things. Okay, so antiderivative, pretty easy to do, kind of fun actually. Now, the name for the antiderivative, another name for it is the indefinite integral. Show me another one, Groom. Okay, fine. The antiderivative of secant squared. Who is he the derivative, in other words? Oh, he's the derivative of tangent. That's right, baby. Okay, we do this all day long. Well, not for all day, but we're going to run out of fun stuff here pretty quick. Again, these are the ones that basically you've committed to memory. So when you see them, you should be like, oh, I see. I see, said the blind man. Yes. Mm-hmm. Okay, so for instance, this guy right here. That's on your homework. I don't want to do that one. This one. This freaks a lot of people out. Don't be panicked. You should break this into two pieces. Which, of course, is saying the same thing as saying, hey, that's 12 x to the minus 2 minus x to the minus 1. So let's do this on this deal. Now you're like, wait, x to the minus 1, I'm going to plus 1 and get 0. No, stop it. That's ridiculous. You want to leave this one the way it is. Well, how do I know? Again, I'll show you in a second. Okay, so I take the integral of the antiderivative of this thing. I'm going to add 1 to the numerator. So I get x to the minus 1, and then divide by negative 1. This one is simply ln of x. Because again, think about it. This is x to the minus 1. If you add 1, you get 0. Divided by that. That's the problem. See that? That's how you know that you can't do that problem. So the final answer is negative 12 over x minus ln of x. Let's see. Okay, now think about this for a minute. Here we go. Obviously, if you're doing the derivative, you would get the derivative of this thing would be e to the negative 3x plus 4 times negative 3, right? You can all see that's how that would work because of the chain rule. Well, what do you think the antiderivative is going to be? Well, I feel like it's still going to be this e to the negative 3x plus 4. I think you're right. But the difference is I need to divide by the derivative of this numerator. So divide by negative 3 plus c, of course. Now, does that work? Well, I think so, because now if you have negative 1/3 e to the negative 3x plus 4 plus c, if you take the derivative of that, you're going to get this thing here is the derivative, yes, but there's also this negative 1. There's also this negative 1/3 out front. And what happens to those guys? They cancel, and you're left with just that. Okay. I wonder, can you figure out what this one's going to be? Well, sine comes from negative cosine. I agree with you. Now, wait a minute. Is this going to work? Well, what's the derivative of this thing? Well, the derivative of this is sine of 2x times 2. Are you with me? Well, what are you going to do? Well, so in other words, we need to then divide by 2. So your final answer would be negative 1/2 cosine of 2x. Let's see. Now, we'll talk more about how to come about that as opposed to just thinking about it. We'll do a lot more of it later on. It's actually pretty straightforward when you think about it. About 5 minutes. Uh-huh. Now, for instance, suppose I told you this. Suppose this is Here, don't peek. Don't peek, I said. All right, think about this. One of these guys is f of x, and one of them is the antiderivative. So we'd say this, f of x, little f of x, this is the derivative. And cap fx is the antiderivative. Well, how do we know the difference between them? Well, think about this. That means f of x is the slope of big F of x. Interesting. So one of them is the slope of the other one. Well, which is it? Well, if this guy up here were the slope of this one, then right in here, this guy here should have a 0 because there's 0 slope, yes? What do you see there? It looks like a minimum. That's why there's a 0 slope. Oh, what does that look like? That looks kind of like a maximum. That's a 0 slope. That's a minimum, 0 slope. Hey, this doesn't really get all the way to the top again, but yeah, it gets up kind of steep into this neighborhood, and then it comes back down. So this guy is f of x, and this guy is big F of x, or if you prefer, this is f of x, and this is f prime. I don't really care if you prefer it or not. That's not how I would do it. Not when we're talking about antiderivatives. Antiderivatives, we just use cap f for the antiderivative. Okay, that's just how the big kids do it. That's how we do, you know? All right, nice. Okay, so suppose I told you, just for grins, now this is just for grins, dy dx is cosine x. dy dx is cosine x. Further, let's say I tell you that the cosine of 0 is 3. Okay, check it out. From whence did this come? I don't know. Let's find out. Well, this is minus sine of x plus c, right? This is my y value. So in other words, what we're saying is y of 0. Oops. What we're trying to say here is y of 0 is 3. Sorry about that. So when you put it in, what's the sine of 0? The sine of 0 is, that's right, 0. So your c then is 3. What is the difference between that function and this function? It's been shifted up. Does it change the shape of the graph? No. Does it change the slope? Not a bit. So that's just what this part's about. Let's do a couple more of them here so you get the hang of it. Suppose you had dy dt equal e to the negative 3t. Then y would be equal to the antiderivative e to the negative 3t. And furthermore, let's say that y of 0 is 5. Well, then what I'd end up with is y equals negative 1/3 e to the negative 3t plus a constant. Y of 0 would be negative 1/3 plus c, and that's supposed to equal 5. So c better equal 5 1/3. And so my final answer then would be equal to something along those lines. Okay? Yay! Now, we'll build into something going forward later on. For instance, suppose I told you that, hey, f double prime of x is equal to negative 9.8. Antiderivative of that, of course, is f prime. Well, that's the antiderivative of negative 9.8. Well, if you do the math on that, what you find is that's negative 9.8x plus a constant. For those of you in physics, that should look vaguely familiar to you. And then what is that initial value? Well, what this is acceleration. This is velocity. And then c is your initial velocity. So if x equals 0, then what you end up with is you'll end up with, I don't know, let's just say, well, let's just say this is f prime of 0. I'm losing my mind. And we would say that this is true. Because at 0, you would have 10. And then if you wanted to find f of x, well, that would be the antiderivative. Anyway, let's just make up a number, so equals 3 or something, whatever. So then that means that f of x is equal to negative 9.8x divided by 2 squared plus 10x plus c. And then at 0, it had to be 3, so this is negative 4.9x squared plus 10x plus 3. And that right there would be your final answer. And that's where that comes from. Okay, there's that relationship between derivatives and antiderivatives. Okay, we already know that going one way. Now with this chapter, the whole rest of the book, we're going to talk about the other half of the equation. Okay, now we're going to do a lot of cool stuff with it. Today it's pretty much just doing them and getting comfortable taking antiderivatives. All right, good luck.